Yeah, welcome to Analog Microelectronic Circuits class. This is Unit 2 and we are in lecture 14. And for the past three classes, we were doing problems on BJT. And still there are a few more questions to be discussed from tutorial 2. So we'll continue with that. I hope the previous class, yeah, we were discussing about this common emitter with degeneration, and I have given you the formula and asked you to try out the answers for input impedance, output impedance, and voltage gain. I hope you got these answers. Can I get some response here? You got the same answers what I have given. What about others? All right. Now I am not asking the question how many of you tried. So from the responses I can see, yeah, few of you have tried and you got the answer. But still, if you have some doubts regarding that, we shall definitely discuss offline. Right. So continuing. So I think from the 7 questions we did question numbers 5, 6, and 7. We also did question number 1 and 2. So the only remaining questions are 3 and 4. So let me start with question number 3 first. So question number 3 in tutorial 2 is a voltage divider biasing circuit is given, and yeah, let me draw the question. Voltage divider biasing circuit is given. So the question is to actually design or design the values for this RC, RE, R1 and R2. But some certain other information, sir. The question is to design the values for RC, R1, R2. Yeah, RE is given. Okay, all right. RE value is given as 1.5K. IC is given. IC is given as 1.5 milliamps. And VCE is also given. VCE is equal to 4 volts. Now the beta for the transistor is 50. And one extra information what is given here is called as SICO. Can I know what is this SICO? Any idea? It is given as 10. Have you?
The stability factor.
Yes, yes, Karthik, that is right. So SICO is called as stability factor. So if you remember, I don't know whether I can say if you remember, because we know to bias BJT we have different circuits. So and voltage divider is one type of biasing. Other than voltage divider biasing, there is something called as fixed bias. There is emitter to base bias. Sorry, collector to base bias. So there are different biasing circuits are there, and each of the biasing circuit has its own stability factor. So the stability factor for this voltage divider biasing is actually 10, close to 10. Now to start with this, yeah, I can involve you guys, but still I just want to give you the formula for the stability factor. I hope you have seen this formula even in your basic electronics class. RTH plus RE divided by RTH plus RE into beta plus 1, right? I hope you have seen this formula in your basic electronics class. If not, you can ping me here. All right, so with all this data, how will you start? So the question is to decide and design the values for R1, R2, RC and RE in such a way that the operating point should be the given VC and IC, and stability factor should be close to 10. So how to start the design? Okay, let me check with yeah, Noel. Noel, are you there, Noel?
Yes, sir. Yes, sir.
Yeah, Noel, how to start with this kind of question? So you are supposed to find the values of R1, R2, R3, and RE. Yes. You have something to say, Noel?
Just a minute, sir.
All right. Yes. Yes, Noel, you can unmute so that I can help you.
Yes, sir.
Yeah, go ahead. What do you want to say? All right, Noel. Okay. So let us come back the question. So the very first thing what you can do here is you can actually find all the currents, right? Because IC is given. So IC value is given as 1.5 milliamps and beta is given as 50. So you can find what is IE and also you can find what is IB. So can you quickly tell me the values for IE and IB? So those who are getting answers can post. Yes. Okay. IC is 1.53. Okay. IE is 1.53 milliamps and IB is 30 micro. Okay. So 30 micro is IB. Right. Now, how to go about and find the values next? Noel, you want to add something now? So now you have currents with you. So how will you find the resistor values now? Noel?
Sir.
Yeah, you have the current values now. So how
Yes,
to
sir.
find? Yeah, how to find? So RE value is known. RE value is known as 1.5K. So how to find RC value? How to find RC value?
12 minus VB.
12
12
minus
minus VC, sir.
12 minus VC. So what is VC? So
12
what is?
minus VC by RC is equal to IC.
Yeah. So what is VC in this case? How to find VC? Right. What you told is right. So let me write this. You are telling RC is equal to.
Sir, VCE is equal to 4 volt.
Okay, VCE is 4 volt, but if I want to find RC, RC can be written as 12 minus VC divided by IC. This is right. Now, how to know what is VC? VC,
VCE is equal to VC minus VE.
right?
VE is equal to IE into RE.
Yes. So from VC you can find VC. Tell me what is that. So VCE is given as 4 volt. So
4
find
volt.
VE and tell me what is VC. So if others have answers, you can post it. VC, yeah, I think Noel is calculating.
VC 6.295.
Oh, okay, yeah. So VC, yeah. So VC can be written as VCE plus VE. Here VC is already 4 plus I think V is close to 1.5K into the current is 1.53 milli, which is 2. 295. Yeah. So what is the answer, Noel? 6 point.
6.295.
Very good. Yes. Thank you, Noel. Yeah. So your VC is 6.295. Now how to find RC? RC is 12 minus 6.295 divided by the current IC. Current IC is actually 1.5 milliamps. So what is RC value? 12 minus 6.295 divided by 1.5 milli, which is 3.803 K. Yes, 3.8 K. RC is 3.8 K. Yes, Bhavana. Yeah, RC is 3.8 K. I think many of you got the answer. Oh, you got 3.72. Okay, can you check it again, Bhavana? I think you will get exactly 3.8. All right, so that is done. Now, if you look at the input side, you need to find R1, R2 also. So one thing we know that we can convert this into Thevenin equivalent. And if you do that, I can get one equation for RTH. RTH is R1, R2 divided by R1 plus R2. So both R1 and R2 are unknown. Now, from the stability factor equation also, you have what is RTH, right? So because Re is known, beta is known, so you will get another, you will get the value for RTH, right? So you will get a value for RTH here, and yeah. So let me convert that. Let me write that equation, write that question in this form. VTH. This is RTH, and now I have the transistor here. Right. So this is 12. RC value is now 3.8K and the other one is 1.5K. So this is 3.8K, 1.5K, and other things are unknown. Now we are supposed to find the value of R1 and R2. Yeah. So can you guys tell me how to proceed now?
Sir, we can also use KVL, no, sir?
Yes, we can use that. We can use that here. So let me write that. So I can write. Yeah. First, let me. Why to apply KVL here?
So we can
Because
find VB from
Sir, with the
V.
yeah,
stability factor, we can find RTH, no, sir?
yeah, we can find RTH. Yes. Okay. So let us do that first. Tell me what is the value of RTH from the stability factor equation. Meanwhile, yes, somebody else was telling you can write VTH or VB, that is 12 into R2 divided by R1 plus R2. Right. So VTH can be written as 12 into R2 by R1 plus R2. But now I can find what is my VTH value. Yes, that can be done. Okay, let me know what is RTH value now. Yes, RTH you are getting close to 16.792K. Yes, RTH is 16.792K. So now I can, yeah, I got one equation for VTH, which is, now if I get value of VTH, then it is little more easy for me. So how can I write VTH? VTH can be written as IB into RTH plus VBE plus IEE into RE. I hope this is clear. This is what somebody else was trying to say, where you can write a KVL. So this drop plus this drop plus this drop is actually equal to VB or VTH. Since I know the value of RTH, I can find what is VTH now. So yeah, okay, you're getting VTH as 3.498. I didn't check, so I'm taking that value 3.498 volts. Others also can find it. So this is VTH. I think the rest is direct from here. I'll get R2 by R1 plus R2 as 3.498 divided by 12, and I already know R1 R2 by R1 plus R2 is 16.792K, right? So for this, if you substitute this ratio, you will get R1 first, and then from that you can get the value of R2. Yes, Akram, what is it? 16.792. Oh, you are telling RTH value. Yes, yes. If you have doubts in this, please ask. What I have done is I have taken, I wrote an equation for VTH. From that, I expressed one ratio like R2 by R1 plus R2 as this, and that I'll substitute in the RTH formula, and we'll get first R1 and then I'll get R2. So what is R1 and R2 value? What are the values of R1 and R2? R1 is 57.6, okay, 57.6K, okay, and R2 is 23.7, okay, 23.7, yeah. So this R1, R2 by R1 plus R2 is will be a 16.79. Oh, is it? Okay, let me check. Yes. I hope all of you got the answer. So what we did is, you have the question was a simple voltage divider circuit, and you were asked to find the values for R1, R2, and RC with the help of stability factor SICO. First, we obtained the value of RC by finding the currents first. Then we wrote when we obtained the what is VC, and through VC we got the value of RC. Then from the stability factor we arrived at the value of RTH, and using RTH we obtained what is VTH value. And yeah, with RTH, with this loop equation we got VTH value. Then by substituting we got the values for R1 and R2. Now if this is clear, you can definitely you can try for next question, which is question number 4. Question number 4 is a complete design. So 3 was a simple voltage divider, but 4 question is design a CE amplifier using a silicon NPN transistor with voltage divider biasing. To have operating point, yes, it is given that your VC should be equal to 5.8 volts, IE should be equal to 1.5 milliamps, and SICO, which is stability factor, is equal to 20. Also given that small signal voltage gain of the circuit is equal to minus 125, and it is given that you should take VCC as 16 volts and beta as 79, also R naught as 20 kilo. Now with all these specification, you are supposed to design the values of R1, R2, RC, and RE. After that, you should also find input impedance and output impedance values. So this is quite a big question, and you can expect this kind of questions in your exam, maybe for 10 marks or 12 marks, right? So who want to help me how to solve, how to start? So any volunteers for getting the answers for this?
So they have told voltage divider biasing, so you can follow the same procedure as the previous problem.
All right. So yeah, the first step, let me just draw a circuit here so that we'll always have a reference, right? So I am actually using voltage divider bias. This is VCC is 16. I have no idea about the component value. So R1, R2, RC, RE I am leaving as as. Now, since it is given that it is common emitter amplifier, I am using all the coupling capacitors and bypass capacitors, and connecting the source signal here. I'll call this as V signal, and this is the point use take output. Right. So this is the circuit, and now the beta of the transistor is given as 79. Right. Okay. Yeah, we have VCE value. Yes, we will be definitely using this VCE value first. Yeah. So go ahead and tell me how to start. Yeah, as you mentioned, I think Manikandan. Yes, Manikandan, as you told, we have to start in a similar way as how we did the previous question. So I would say the very first thing is, let me write it in steps. The very step is first step is to calculate the currents, because that is something which we can directly do. So given that IE is 1.5 milliamps, let me write the values of IC and IB. That is straightforward. Can I get answers here? Manjunath S. Yeah, already answers has come in. IC is 1.48 milliamps, and IB is 18.75 microamps. Yes. All right. So that is IC and IB. All the currents are known first. Now, what is next step? So in the previous case, RE, the value RE was given. Now RE is not given. Even RE we need to find. So how to start? Any idea? Manjunath S, are you here? Yes, Manjunath. Tell me, Manjunath, how to proceed now? So what I know now is I know all the current. So this is IB, this I know, IC I know, and IE I know. Now I am actually wondering about these resistor values. So probably the previous approach of writing RTH, VTH, all those things will work to find R1 and R2. That is true, that we can use. But then in that question, RE was given, and from that you were finding RC. But now both RE and RC, both are unknown. So what do you think, Manjunath, we can do in this case? So look at the given parameters. SICO, anyway, I cannot touch that now, because for that I know I should have some information about RE. So what else can be used? Are you able to think, Manjunath? Manjunath, are you there? Hello. All right, Manjunath, you can keep yourself mute. I'm not able to hear you. Okay, let me check with Maunav. Maunav?
Yes, sir.
Yeah. So are you getting any idea?
Sir, if we only, like, according to me, if we only do DC analysis, we'll have 4 variables and 3 equations. So I feel we have to do AC as well.
Yes, very good. Yeah. So that is a yeah. Kirtan, I saw your answer. Yeah. So what do you think, Maunav, we can do now with AC analysis?
Use the AV voltage gain equation.
Very good, very good. Yes. So my second step here is actually to use the voltage gain equation AV. AV is given as minus 125. So I have to write what is V out by V signal in this case. That is given as AV, right? So can you tell me what is V out by V signal? For that, I should definitely have a small signal picture. If I do that, can you tell me what will be the small signal gain of this formula? Okay, I'll quickly draw the equivalent circuit. This is R pi, GM V pi, and this voltage is V pi. Now I need to add the components as per the circuit diagram. So at emitter, Mona, are you there?
Yes, sir.
Yeah, Mona. So at emitter, what happens to emitter terminal?
RE.
RE, but will RE be there?
No.
No.
Because
Why? Yes, capacitor is there. Yes, thank you, Mona. Yeah. So let me check few answers has come in. Yes, Kirtana, yes, we can use gain equation. That is what I'm trying to do here. So I did emitter connection this. Now at base, I have two resistors R1 and R2. Let me put it as RTH or RB, anything is okay. Again, this capacitor is short and here I have V signal. Now the voltage V signal is same across RTH and R pi, that is same. Now, since R0 is given in this case, in the small signal model, I should include that R0 as well. Now, towards the right side, I can draw RC here. And this is V out. That means looking at this equivalent circuit, I can write V out by V signal as, let me check with Charan. Charan, are you there? Charan Kumar.
Yes, sir.
Yeah, Charan, can you tell me what is V out by V signal in this case?
Sir, minus GM into RC.
Minus GM into
RC.
only RC?
Only RC, I think.
Oh, okay. Okay, Charan. Praveen, are you there, Praveen?
Yes, sir.
Yeah, Praveen, can you tell me what is voltage gain in this case?
So minus GM into RC parallel R naught, sir.
Yes, it is R0 parallel RC. So, Charan, I think you haven't seen this. There is R0 we need to consider here. It is R0 parallel to RC. This is given as 125. I can find the value of GM. R0 is given. From this, you can get the value of RC. Yeah. So, you guys can calculate and let me know what is RC. So to find RC, you should have first calculated GM. GM is IC by VT, which is 1.48 milli divided by 26 milli, which is close to 56.9 milliamps per volt. That is GM. So what is the value of RC?
Sir, shouldn't this be micro amps per volt? So GM.
Which one?
So GM, sir.
GM is?
So 56.9 micro amps per volt.
No, it is milli only, no, because IC by VT, IC is 1.48 milli and VT is 26 milli.
Yes, sir, that's why only I have seen.
Yeah, so
it's 0.056 milli amps per volt, sir.
No, your IC is 1.48 milli, right?
Yes, sir.
What is your VT?
So 26 millivolts.
Yes, so what is 1.48 by 26?
So that's 0.056 milli amps per volt.
Check your calculator. Are you seeing a milli there or it is 0.0569?
Sir, it's 0.056.
9. That means it is 56.9 milli.
Oh, yes, sir.
Yeah. So what you are seeing is not milli, it is without any milli or micro. Yeah. So if you do that, you will get RC value. Yes, you guys are getting RC as 2.46 kilo ohms. Yes, RC is 2.46 kilo ohm. Yes, very good. So that is my second step. From voltage gain expression, I got RC. Now, all right. So Kirtana, can you tell me how to get, how to proceed further?
Sir, like same thing. Now remaining is same because we know RE. So we'll use VC.
We do not know RE, right? We know only RC.
RC. Okay. Huh.
Yeah.
So then we'll write KVL around that loop.
Which loop we'll write?
out like RCRE, that loop.
Very good. Yes. So we'll go for this loop and we'll write KVL. Yes, that is your third step. So what is the KVL there? VCC minus ICRC minus VCE minus IE into RE equal to 0. In this, I know VCC, RC, VCE, IE and IC. So I can find RE. RE is VCC minus ICRC minus VCE divided by IE. So what is the value of RE? Any answers for RE? Okay, it is 5.07. It is 5.07 K. I'm taking your answers. I do not have answers with me now for this question. So 5.07 K is RE. All right. Now we can find. Now we can directly find the values of R1 and R2 following the same previous procedure. So please do it and tell me what is the value of R1 and R2. Yeah, Harshita, are you there, Harshita?
Yes, sir.
Yeah, Harshita, what is next step?
Sir, using like RTH. Sir. Yes, sir. First, we have to calculate RTH, sir, and then what we did previously, we have to do that and find out R1 and R2.
All right, yeah. So do that and let me know what is the value. Yeah, okay. You guys are getting RE is 4.3. Okay, let me calculate RE. VCC here in this question is, what is VCC? 16. 16 minus, what is IC here? IC is 1.48 milli into RC is 2.46 kilo minus VCE. VCE is given as 5.8 divided by IE. So your IE value is 1.5 milli. Yes, it is coming around 4.37. All right, I think Harshita, you can check for the answer. There is a small difference. It is 4.372 kilos. Probably you would have missed, you would have put IE value there. I don't know.
Yes, sir. I did a mistake.
Yeah.
Calculation. Yes.
All right, no issues. So you will end up with RE as 4.3. That you can go back and you can repeat the same step as before. You can convert the circuit and you can write the equation for VTH. You can do all these things and finally tell me what is the value of R1 and R2. That will become your fourth step. And after that, you can find Z in and Z out. I hope you guys can do this. So do it and let me know. So with this, we'll wind up today's class. So I'll wait for your answers.